Hi, I am Miss Janice. Let's continue with infinite limit today, which it is related to vertical asymptote. Do you know what is infinite limit? When x is approaching a value, say a, and y is approaching infinity or negative infinity, this is the case which representing infinite limit. It means the limit for y is no limit. It can be going to a very big figure without any limit, or going to a very small figure without any limit, negative infinity. So the way to indicate it will be when x approaching a, the limits for y will be either positive infinity or negative infinity. This is the infinite limit. To evaluate a limit, when we do the direct substitution, and if we get constant over 0, a value constant which cannot be 0 over 0, what does it indicate? For instance, after I do the direct substitution, I get 2 over 0 or say negative 1 over 0. What does it indicate? Let's see the example. X approaching 1 negative. The limit for 1 over x minus 1 is question mark. So let's talk about the actual situation. X approaching 1 negative means x could be a value which is very close to 1 but slightly less than 1. So it could be 0.999. It can also be 0.99999 and more, 9 to go. Then the value for the expression 1 over x minus 1. You use the calculator, substitute x equals to 0.999 into the expression here. You will tend to get negative 1000. Let's substitute another value, which is closer to 1 from the left-hand side. Substitute x equals to 0.99999 into the expression here. For this case, you will get negative 100,000. So what does it indicating? It means when x is approaching 1 negative, 1 over x minus 1 will be approaching a very small figure, which is negative n. So the answer for this must be negative infinity. However, how do we do it without having this being shown? You shouldn't show this. So how do we do this? So every time when the question given to us, we first do the direct substitution. And if you get something over 0, a constant over 0, say this question, x approaching 1 positive. When I substitute 1, 1 over 0. So immediately I tell myself this must be related to infinite limit. The answer must be related to infinity or negative infinity. Then which should it be? It can only be one scenario, either positive or negative. So we need to check the sign. How? To check the sign, we take a number as a representative to check the sign. So take 1.1 in this case, because this is 1 positive, slightly more than 1. So substitute it here. 1.1 minus 1, we get a positive value, positive 0.1. So positive over positive value, it is positive. So immediately we erase this part. Then this will be the answer. So you will notice there is no working need to be shown. All the process you can actually work it out on rough paper. You shouldn't do this, which is very time consuming. So something over 0 means related to positive or negative infinity for one-sided limit. So these two are the answers which I have shown you earlier. Relation of infinite limit with vertical asymptote. So bear in mind, every time when you have infinite limit, which means the limit is equals to negative infinity or positive infinity, then there will be a vertical asymptote at this point. So the vertical asymptote happens at x equals to 1. It must be an equation. Vertical asymptote is at x equals to 1. Let's continue with one example. Say limit when x approaching 2 negative for 3 over x minus 2 squared. Question given to us. first do the direct substitution. Let's substitute 2 in this case. 3 over 2 minus 2 squared, we get 3 over 0. This is a constant over 0. When we get a constant over 0, tell yourself it must be related to infinite limit. This is one-sided limit, so the answer must be negative infinity or positive infinity. We need to check the sign. Is it positive or negative? How? Take a value as a representative to check the sign. Is it positive or negative? So here 2 negative means slightly less than 2. By right, it should be 1.999999. However, now we are just needing to check the sign. So take 1.9 as a representative just to check the sign. So substitute x equals to 1.9 here. 1.9 minus 2 is a negative value. Being squared, a square number is always positive. So positive on the denominator side, and numerator is also a positive value. So positive over positive, the answer must be of positive sign. It is positive infinity. Next. What about this? So first, do the direct substitution. X equals to 2. We get again something over 0. For one-sided limit, immediately tell yourself it must be either positive or negative infinity. Need to check the sign. Let's check the sign now by taking a number as a representative. What number do you think you should take in order to check the sign? For this case, 2 positive, slightly more than 2. We take 2.1 to check the sign. By right, it should be, what number should it be by right? 2.00001. However, we can just take 2.1 as a representative here, just meant for the sign. 2.1 minus 2 is positive. Being squared, it is a positive value on the denominator side. Numerator is positive, so overall, it is a positive sign. So the answer for these two are both positive. When we have infinite limits, this case, you must know that there must be a vertical asymptote. So for this case, the vertical asymptote is at what? X equals to 2. Hope you understand. Move on. What about the two-sided limit? When x approaching 1, the limits for 1 over x minus 1. So first, let's do the direct substitution. We get a constant over 0 case when we substitute x equals to 1. Constant over 0 case related to infinite limit. Earlier, we know that for one-sided limit, the answer must be either positive infinity or negative infinity. However, this is two-sided limit, so we need to check both the one-sided limit. We need to do the left-hand limit. We also need to do the right-hand limit in order to draw the conclusion. So for the first case, 1 negative, 1 over 1 minus 1, 1 over 0 case. For one-sided limit, infinity or negative infinity. Next, check the sign. 1 negative means slightly less than 1. 0.9 minus 1 is a negative value. On top is positive. Positive over negative, this is negative infinity. Second case, 1 over 0 case. For one-sided limit, must be infinity or negative infinity. Our job is to check the sign now. 1 positive, take 1.1 as a representative. 1.1 minus 1 is a positive value. Numerator, it is also positive. So overall, it's a positive infinity. So these two limits approach to two different values. One is negative n, negative infinity, and one is positive n, negative n. Therefore, what is the conclusion? The conclusion for this two-sided limit shouldn't have any superscript. Let's erase this. Will be D and E does not exist. If I ask for the reason is because the left hand limit is not equal to the right hand limit. It's not equal to the right hand limit. So for two-sided limit, when we do the direct substitution, and if we get a constant over 0 case, the answer could be infinity or negative infinity or D and E. We need to come up with the one-sided limit in order to draw the conclusion. In this case, one is negative n, another one is positive n, two different approaches. Therefore, the two-sided limit is D and E. If both equals to negative infinity, then the two-sided limit will be the same value, negative infinity as well. If both positive infinity, then the two-sided limit will also be positive infinity. Let's see from the graph to evaluate all this. When x approaching -1, negative, what is the limit for gx? -1, negative, -1, negative, slightly less than -1, go down because the graph is below x-axis. We notice the y value, the gx value is going to the negative n. There's no limit for the y value when x approaching -1, negative. It means it is negative infinity. This is infinite limit. -1 positive, -1 positive, go up, go to positive n. The answer for this question will be positive infinity. What about limit for gx when x approaching -1? This is two-sided limit. We have to check the two one-sided limit. Negative n and positive n, one positive, one negative, different approaches, so D and E. X approaching 0, this is x equals to 0. For two-sided limit, we have to check the left end as well as the right end, both approaching 0. So this is 0. When x approaching 2, two-sided limit again, left end and right end. So left-hand side, right-hand side, both approaching negative infinity. They approach to the same value. So the two-sided limit exists. It is negative infinity. Let's see example 7 in page 8, part B. Evaluate all this. So let's see, x approaching 2 positive. Let's substitute x equals to 2. 1 over 2 minus 2, 1 over 0 case. Something over 0 case for one-sided limit must be related to infinite limit. Is it positive or negative? Let's check the sign. 2 positive means take 2.1 as a representative to check the sign. 2.1 minus 2, positive value. Positive over positive is positive infinity. Number 2, x approaching 3 negative. Let's substitute 3 directly. 2 over 3 minus 3 square. Something over 0. One-sided limit, right? For something over 0 case of one-sided limit, the answer must be related to infinity. Is it positive or negative? Let's check the sign. Take 2.9. 3 negative means slightly less than 3. 2.9 minus 3, it is negative. Being squared, positive. Positive over positive, so positive infinity. What about number 3? This is two-sided limit. Let's substitute x equals to 2 first. Something over 0 case. For something over 0 case of a two-sided limit, we have to check the left end as well as the right end. For 2 negative, so 1 over 0 related to infinite limit, check the sign by taking 1.9 as a representative. 1.9 minus 2, negative. Positive over negative, so it is negative infinity. For this question, we have done it earlier. It is positive infinity. Based on these two, we can draw the conclusion for the two-sided limit. This question will be D and E because both the one-sided limit are approaching two different values. Number 4, substitute x equals to 3 first, something over 0. This is two-sided limit, so we need to come up with the one-sided limit. So for the first case, we have done it in question 2. It is positive infinity. Let's check for the second case. Substitute x3, we know that this is something over 0 case. For one-sided limit, the answer must be related to infinity. We need to check the sign. Take 3.1 as a representative. 3.1 minus 3, positive value. Square it is a positive value. Positive over positive is still positive. These two values are the same, positive infinity. Therefore, the two-sided limit for question number 4 will be the same value as well, positive infinity. So if you do not know how to do manually in order to check the sign, you are advised to use the calculator, key in 3.1 minus 3, bracket, square, check what is the sign of the value. Please do not take the value. What we want is the sign. Next, substitute x equals to 2 directly. Negative 5 over 2 square minus 4, it is something over 0 case. Something over 0 case indicate that it is an infinite limit. However, for two-sided limit, we have to come up with the left hand as well as the right hand limit in order to draw the conclusion. For the first case, 2 negative. Sub in something over 0 case, one-sided limit related to infinity. We need to check the sign. Please take your calculator, substitute x equals to 1.9 in order to check the sign. 1.9 squared minus 4, you will get a negative value. Negative over negative, it is positive. While for the second case, must be related to infinity as well because it's negative 5 over 0 case when we do the direct substitution. Check the sign, take 2.1 as a representative for two positive case. Use your calculator, 2.1 squared minus 4, you will get a positive value. Negative over positive, it is negative. Then only we can draw the conclusion for the question. When x approaching 2, the limits for negative 5 over x squared minus 4 is D and E. The reason is because these two are two different values. I hope by now you know whether the question is related to infinite limit or not. When we do the direct substitution, and if we get something over 0, it must be related to infinite limit. For one-sided limit, the answer must be either positive infinity or negative infinity. But for two-sided limit case, we have to come up with the one-sided limit, left end and right end, in order to draw the conclusion for the two-sided limit. I will continue with more examples in the second video. Thank you.